subject to a moment at the end. We have seen it, right? Today, I will teach you some simple problems on simply supported beams. We will see simply supported beams. How to deal with simply supported beams. That's a simple problem, right? Here we have a simply supported beam subjected to point load capital W at its center. Please, all of you remember, either you can use capital W or capital P. Okay, anything you can use here, rotation. So, subject to capital W at the center. Okay, say the deflection is y suffix C at the point C here. I have named it A, B, and C. Okay, so the deflection at the center is YC. Obviously, the deflection will be maximum at the center. Okay, if the beam deflects, this is the deflection profile. For visualization purpose, it is drawn in a considerable manner, right? So, it is obvious that the deflection is maximum at the center. And the angle of rotation, that is slope, nothing but slope, is theta A, means at A point A, the angle of rotation or the slope is theta A. At B, the slope is theta B. It is obvious due to symmetry. Due to symmetry, it is a symmetrical beam, a simply supported beam, symmetrical, subject to point load at its center. So the deflection is maximum at the center. Moreover, the theta A is equal to theta B. The angular rotations are same at point A and B. It is well known to us. Okay. So the span of the beam is L, and consider a section XX at a distance X from A. Okay. Now, what is the bending moment at this section? Okay. What is the support reaction here? The load is W. Okay. Only one single point load at the center. So the reaction will be half of it, W by 2. W by 2 is the support reaction. Right. Now the bending moment at this section is, you can investigate right side of the section or left side of the section. If you investigate left side of the section, what is the bending moment? This load is acting upward. So the bending moment due to upward force is positive. I told you. W by 2 into the perpendicular distance is XC here. W by 2 into X. That is the bending moment at this section. So I have written M suffix X equal to bending moment at the section XX is equal to W by 2 into X. That is the bending moment, a general expression for bending moment in the portion AC. Please listen. This expression is applicable only for the portion AC. Okay. Therefore, we know EI d square y by dx square is equal to minus M. That is, M is nothing but minus W by 2 into X. You have to write EI d square y by dx square is equal to minus M. Therefore, EI d square y by dx square is equal to minus W by 2 into X, because it is plus positive moment, sagging bending moment. Okay, already minus M in our expression is there. That's why it becomes minus here. Now integrating, you have to write integrating EI dy by dx is equal to minus W by 2 into X square by 2 plus C1, integral constant. Okay, now we have to evaluate this unknown parameter, this integral constant, by using boundary conditions. What is meant by boundary conditions? Known value at certain salient points, we know the value of slope, the value of deflection at certain salient points. Okay, they are called boundary conditions, BC, boundary conditions. I have to apply boundary conditions in order to evaluate this integral constant. Okay, what is this? This is the equation for slope. No. So, what do you know about slope? Information about slope. What about slope at A is there? Okay, theta A. What is the slope at B, which is theta B, which are unknown to me? Okay, do I know the value of slope anywhere along the length of the beam? Just think. Okay, come to the center. At the center, the slope is 0, horizontal. The beam is horizontal. If you draw any tangent to the beam at the center, the tangent will make 0 degree with the horizontal. If I draw any tangent at the center, a point at the center, the tangent will be horizontal. So the angle made by the tangent with the horizontal will be, what is that? 0, right? That is why the slope is 0 here. So at x is equal to L by 2, what is meant by at C? At C, otherwise, at x is equal to L by 2 means center. Okay. At x is equal to L by 2, the dy by dx value is 0. The slope is 0. The angle of rotation is 0. So substitute this in the above equation, which implies C1. If you substitute here, C1 okay, minus W by 2 into L instead of S, you have to substitute L by 2. That's why L square by 4 is equal to dy by dx is 0, is equal to 0, which implies C1 equal to WL square divided by 16. Okay, therefore, the slope equation, EI d y by dx is equal to minus WF square by 4 plus WL square by 16. This C value of C1 value I have substituted here. This is equation 1, which is called slope equation. Okay. Now integrating again, you have to write here, integrating again. Okay, the double integration you are doing. The same time you are integrating. EI y is equal to, integrate this one, W by 4 is a constant, x cube by 3. Okay, plus here W by 16 is a constant, W by 16 is a constant. Okay, W by 16 is a constant, where it is integrate area, and you have to integrate this one. Oh, sorry, we have fully a constant. WL square by 16 is a constant. So if you integrate it into x, it comes plus C2. Okay, another integral constant. Same time integration, you are getting another constant C2. You have to evaluate it from the applying boundary conditions. What is the meaning of it? By applying known values at certain salient points, we know the value of deflection or slope or something. Okay, so at A we know that the deflection is 0. At support A, the deflection is 0. As well as at support B also, the deflection is 0. So I am applying they are called boundary conditions at A. In other words, at x is equal to 0. At A, in other words, at x is equal to 0, the deflection y is equal to 0, which implies C2 becomes 0. Okay, if you substitute here x is 0, y 0, the C2 becomes 0, which implies C2 is equal to 0. Therefore, EI y is equal to minus W by 12 into x cube plus WL square by 16 into x. This is equation 2, which is called the deflection equation. Okay, so we have got it. Now, we are interested in determining the slope, theta A and theta B and all. At x is equal to 0, it means at A. Okay, because at A, x value is 0. At x is equal to 0, the theta A, the angle of rotation or the slope at A, angle of rotation, slope, both are one and the same. Already I told you in the very beginning of the class. The slope at A is equal to, you substitute x is equal to 0 in this. Only if you substitute x is equal to 0, sorry, in this equation, I'm sorry, in this equation, substitute x is equal to 0, you are getting only WL square by 16 EI. Theta A is equal to WL square by 16 EI. Okay, that we have got, right? Please remember the slope, if we simply supported beam, substitute to point load at the center. The slope at the ends are WL square by 16 EI. You should know, because many competitive examinations, this is the questions, objective type exam. If you appear any objective type exam for placement, for the employment in the future, they will ask a simply supported beam subject to point loaded center. The slope at the supports is WL square by 16 EI, WL square by 80 EI, WL square by 24 EI, something they will give. You have to choose WL square by 16 EI. You should remember this. That time you cannot do this double integration method and derivation and all during competitive examination. Objective type questions. This way only questions were asked in objective types. Please remember that. When you in the future, if you apply for employment and appear in any entrance exam or any test for a job of employment, okay. I have tried so many exams like that. Even Indian Oil Corporation test, SAIL test, NTPC, even Indian Telephone Industries test. Several exams I appeared after completing my graduation. That time, many objective type questions were asked. Even if you tomorrow if you apply for Indian Engineering Services exam, even IAS exams, civil services exam, in the objective types, this kind of questions will be there. Okay, okay, right. So next, I want to determine slope. Slope is in this simply supported beam. Deflection. Next, I want to determine deflection. In the simply supported beam, the deflection is maximum at the center. Okay, at the center, the value is x is equal to L by 2. So at C, in other words, at x is equal to L by 2, I am interested in determining the maximum deflection. At x is equal to L by 2, y is equal to 1 by EI into, okay, substitute in this equation, x is equal to L by 2 here. Okay, so it becomes W into L cube by 2 into 8 plus WL square 16 into L by 2. Okay, if you do it, you are getting, okay, here 16, here 16 into 32, here 16, here 32. The LCM is 96. So this is minus WL, Okay, sorry, this is 12 into 8. I'm sorry, 12 into 8. So 96 is the LCM. So minus WLS cube plus this is 3 times. So 3 WL cube, right? This is 32, no, right? So if you do it, you are getting Y equal to WL cube by 48 EI. WL cube by 48 EI you are getting. Okay, this you should not forget. This is very, 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 very important. The deflection of a simply supported beam subjected to point load at the center. What is his maximum deflection? If somebody asks you, immediately you have to say WLQ by 48 EA. W means capital W. It's not small w, capital W, point load. Okay. If you don't like to use the notation capital W, you can comfortably use the notation to represent point load capital P. Okay. PLQ by 48 EA. You can say immediately. Many textbooks you can see capital P. Okay, I think I referred to Dimacho on gear that time. He used the W, the same thing I adopted. PLQ by 48 EA. If you don't like WLQ by 48 EA, right? Immediately you have to tell. This you should not forget. This is very, very, very important expression. Okay, deflection of a simply supported, maximum deflection. A simply supported beam subject to point load at the center. What is the deflection at the point load? What is the maximum deflection in it? If somebody asks you, immediately you have to say PLQ by 48 EA. If you don't like WLQ by 48 EA, immediately you have to say. Okay, so I advise you, even if you don't remember the slope, doesn't matter. WL square by 16 EA, but the deflection is very, very important. This expression you have to use ready-madely during your future study and all. Okay, so that is very important here. Next, we are seeing another case, the simply supported beam subject to UDL. Okay, uniform distributed load over its entire span, right? Of small w, of intensity, small w per meter run, per meter length or meter run, right? So small w, UDL is there. So here also the simply supported beam is symmetrically loaded, right? So the deflection profile will be like this. For visualization purpose, we have drawn this much considerable manner. It has been drawn, right? So the slope at A is theta A, the slope at B is theta B. They are equal due to symmetry. They are equal, right? And the deflection is obviously due to symmetry. The deflection is maximum at the center because it is a simply supported beam, symmetrically loaded, right? So the deflection is maximum at the center. Say that the maximum deflection is Y sub C here, right? Now we will see. Consider, please, here I want to tell you another thing. This simply supported beam, you determine the slope theta A now. That is theta B also due to symmetry. You need not investigate a portion CB. Once you investigated portion AC, more than sufficient. Okay, so we have investigated the portion AC. Actually, this beam is divided into two portions, AC and CB. Due to symmetry, portion AC and CB are one and the same. Once you investigated here and determined the slope at A and the maximum deflection at the center, now finished. The job is over. Okay, the problem is solved. You need not again investigate portion CB and consider a section at distance x from either end A, B or A. Such investigation need not be done because theta B is known to us now. Just theta B is nothing but theta A. And moreover, the deflection, maximum deflection center also is same. So the problem is completed, solved. So you need not investigate the other portion, right? Likewise, here also you consider a section XX at a distance x from NDA, say, right? Now, what is the general expression for bending moment? For that, you should determine support reaction. What is the support reaction? What is the total load acting here? W into L span. Okay, that is the total load. Half of it. Okay, WL by 2. Shared, no, half load shared to the support. Half load comes to the support. It gives the reaction, reactive force. The supports offer reactive force. So WL by 2, WL by 2. These are the support reactions. Due to symmetry, easily we are getting support reaction without taking moment about some point and all, without doing all such business. Straight away, we are getting the support reaction because the beam is symmetrical, okay, symmetrically loaded. Also, half load comes to this support, WL by 2, WL by 2. The total load is W into L, half of it is WL by 2, WL by 2 is the support reaction. Okay, now the bending moment at a section XX is equal to, this is upward force. So I told you, when you are investigating left side of the section, okay, either you investigate left side or right side, bending moment due to all upward forces are positive. Bending moment due to odd downward loads are negative because upward force produces sagging bending moment. Downward load produces hogging bending moment. Okay, that you should remember. Right? That is the sign convention we adopt. So WL by 2 into X. Okay, WL by 2 into perpendicular distance is X. I am determining the bending moment at this section. Okay, which is WL by 2 plus WL by 2 into X minus, what is the load here? W into X is the load. W into X and the perpendicular distance, half of it, X by 2. Okay, please remember. W, okay, which is spread over length of X here. W into X is the total intensity of the load, which is assumed to be concentrated at its center of its run. Okay, center of its run. So the distance here is X by 2. That is why it is minus W X square by 2. So I have written general expression for bending moment. Now I am writing. We know EI d square y by dx square is equal to minus m. Okay, therefore EI d square y by dx square is equal to minus m. This plus becomes minus here. Minus WL by 2 into X. This minus becomes plus now because minus m no. That's why W by 2 into X square. I have written here. Integrating, right? EI dy by dx square is equal to minus L by 2 into X square by 2 plus W by 2 into X cube by 3 plus integral constant C1. Okay, now we have to evaluate this integral constant by applying boundary conditions. It means by applying known values of the salient points. Okay, we know, what do you know? Do you know any information about slope? Obviously, due to symmetry, the deflection is maximum at the center. No, at this point, the slope, the beam will not rotate. Okay, if you draw any tangent to the point here, it is horizontal. Okay, the slope is 0 here. The angular rotation at the center is 0. Okay, at x is equal to L by 2, dy by dx value is 0. Okay, which implies dy by dx 0. 0 is equal to, substitute x is equal to L by 2 in this expression. Okay, this into C1. Therefore, C1 equal to, if you determine WL cube by 24. C1 is obtained as WL cube by 24. You just go through this computation later because very short, by today I will mail this notes to you. Don't worry. Okay, so you go through this one. How to substitute in this expression x is equal to L by 2. And if you simplify, you will be getting WL cube by 24. Okay, C1 is equal to, therefore, EA dy by dx is equal to, substitute in this. Okay, this is the expression. C1 you have evaluated, right? So this is the expression, equation 1, which is called a slope equation. Okay, you determine the C1 value, substitute here. So you will be getting, this is WL by 4 into x square. Okay, plus W by 6 into x cube plus what you have determined here, WL cube by 24, equation 1, slope equation. Okay, now we have slope equation. Using this, we can determine slope at any required point. Very good. Next, integrating again, right? You have to write here, integrating again. EAY is equal to, just a few minutes, I will score it for, I will come to that later. I want to just, attendance purpose, I want to just, okay. I want to record the student names for attendance purpose. It is in alphabetical order. Just later I will go see the students' name, right? Who are attending. Today 56 students are attending. So I am recording them. Right? Later I can check it. I can give attendance. I am marking attendance hereafter. I have decided to mark attendance hereafter. Okay. So these are the students attending class. These are the students attending class today, right? It's well recorded. Very good. A few minutes. Just I am taking attendance. Few minutes. Yes. Your attendance is over. No. Very good. Right? Can you be able to see the notes fully? Whether the notes is fully visible to you or obstructed?
Yes, sir.
Is it fully visible? My screen is visible, yes, as it is. Whatever I am doing, everything you are seeing, no? Yeah, yes, my screen is visible to you as it is. Very good. So please see here. Next, EAY is equal to integrate it again. Okay. So this is the expression we got. Because here W L by 4 into x cube by 3 plus W by 6 into x power 4 divided by 4 plus W L cube by 24. It's a constant into x, okay, plus C2 is the integral constant. So I have integrated this expression, okay, sine time. So I am getting integral constant, sine integral constant C2. Now I have to evaluate it. What do you know about this one? The differential is 0 at E. At the support, the differential is 0. That is at x is equal to 0, y equal to 0, which implies C2 equal to 0. If you substitute y0 and x0 here, C2 becomes 0. Okay. So I have evaluated the value of C2 now. Now the expression for differential equation is written as EIY is equal to WL by 4 into 3, 12 into x cube plus W divided by 6 into 4, 24 plus x power 4 plus W L cube by 24 into x. Equation 2, which is called a deflection equation. So this is the deflection equation we have got. Now I am interested in determining slope at the support. What is the value of slope at the support? How do you determine? At the support, x value is 0. At x is equal to 0, theta a equal to, where is slope equation here? Equation 1. This is slope equation. Okay. At x is equal to 0, theta a. Theta a means nothing but dy by dx at a. Theta a means what? Slope at a. dy by dx at a is equal to 1 by ei into, okay. In this expression, you have to substitute x is equal to 0. This becomes 0. Only WL cube by 24 is there. 1 by EA into WL cube by 24. That is WL cube by 24 EA. So theta A, which is nothing but dy by dx at A. Dy by dx, you have to write bracket suffix A, okay, at A is equal to WL cube by 24 EA. This also you should not forget. We have a simply supported beam subjected to UDL. What is the slope at this simply supported end? Now, immediately you have to say WL cube by 24 EA. Okay, these values and all you have to remember for certain standard cases. For certain standard cases like cantilever beam subjected to point load at the end, cantilever beam subjected to UDL, simply supported beam subjected to point load at the center, simply supported beam subjected to UDL. What is the value of slope? What is the value of maximum deflection? All these things, as a civil engineer, you should remember. You should tell immediately, readily. You should keep it in mind. Okay, at least for during your student life. For attending competitive exam and all, right? So next, we are interested in determining maximum deflection. We know in the simply supported beam, the deflection is maximum at the center. At the center, the x value is L by 2. Substitute x is equal to L by 2 in this expression. Okay, at x is equal to L by 2, yc, that is nothing but deflection at the c, which is nothing but y max. The maximum deflection is equal to 1 by EI into, in this expression, you substitute the signed equation L equal to L by 2 here. Okay, L equal to L by 2. If you do it, you will be getting expression like this. If you simplify them, we are getting WL by 4 minus WL L power 4 divided by 96 plus WL power 4 by divided by 384 plus WL power 4 divided by 48. Okay, so the LCM is 384. Okay, for this commonly. So we are doing it, simplifying it. Finally, we got 5W. This is small w, it's not capital W. Remember, it's UDL. 5 WL power 4 divided by 384 EI. This is very, 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 very important. Both the point load and the UDL, you should know this value, deflection value, Y. Okay, so the deflection is frequently you'll be using in your course of study, these values, in your structural analysis and other structural design and all, immediately you should tell. Okay, so we have a simply supported beam subject to UDL. What is the deflection at the center? Somebody asks you, immediately you have to say 5WL power 4 divided by 384 EA. This you should remember. 5WL power 4 divided by 384 EA. This you should remember. Again, I am telling, it is very, very important, which is required during your further course of study, okay, in your future, next semester, okay, you will be having structural analysis and then followed by structural design, concrete design, followed by structural design, steel design, and other allied subjects, precess concrete, and all. Everywhere, you have to tell immediately these values. Just because these values will be frequently used during your course of study. So I advise you to remember it, right? We have a beam, simply supported beam, subject to point load at the center. Say W or P, whatever it is. What is the deflection at the center? Immediately you have to say WL cube by 48 EA. No, now I have a simply supported beam subject to UDL. What is the deflection at the center? Immediately you have to say it is 5 WL power 4 divided by 384 EA. Immediately you have to tell, right? I advise you to remember these values. Right? Nice. Next, we are going to see another cantilever beam. Suppose you get a problem like this. How to deal it? Okay. I have a cantilever beam subject to UDL near its support. Already we have seen a problem. Cantilever beam subject to UDL, partial UDL. Already I have seen. Okay. While dealing with the cantilever, I told you something. Partial UDL. Okay. You have not seen? No. No problem. Now we are going to see. So, only point load at the center. Okay. Now partial UDL. Right. How to deal this kind of problem? Just to see here. Just I am telling. Right. So here there's a cantilever beam. Now we are seeing another case. Subject to UDL at a distance A from the fixed end. Right. Please see here, the UDL, the beam bends up to under the UDL. Under the UDL, there is a bending action. The beam bends. Thereafter, since there is no load acting here, the beam is a straight line. It will not bend because there is no bending moment. There is no bending moment thereafter. Okay. That is why the beam will be a straight line here. Okay. Now, how to deal this? Here, say point A, point B, point C, where the UDL ends. Say it is point C. Here the deflection is y suffix c. The slope is theta c, theta suffix c. The same slope will be there here. The rotation at the free end is same theta c. But the deflection at the free end is yb is equal to yc plus this theta c into this length, L minus x. Sorry, L minus a. L minus a is this length. Okay. So the yb is equal to yc plus this arc length here, this arc length you have to add. Okay, how do you get arc length? Yc into L minus A. This way you have to determine. If this kind of problem is asked with the numerical values, how to deal it? Okay, just with the notation I am explaining here. This is some guidelines. Okay, there is just guidelines. You are doing engineering course. We cannot do spoon feeding kind of teaching, right? You are doing professional course. You have been admitted based on your merit. Okay. At the college level, that too at the professional course level, at engineering level, we cannot hold your hand and teach. We cannot do spoon feeding kind of teaching. You have to work hard. You have to apply your mind and learn so many things from our guidelines, from our teaching, right? So theta c is equal to, already we know a cantilever beam subject to UDL. What is the deflection at the free end? Suppose the cantilever is up to this. Forget about this portion. The cantilever beam is up to this. What is the rotation at the free end? We know WL cubed divided by 6CA. Now it is A only, no? We are using the rotation A. That is why WA cubed by 6CA. That is the rotation at C, theta C. These values are already known to us. YC is equal to, what is the deflection at the free end of a cantilever? Just to forget about this. What is the deflection at here for this cantilever? Here it was WL power 4 divided by 80A. Okay. Here the L is nothing but A. That is why WA power 4 divided by 80A is the deflection. Okay. Now this theta B is equal to theta C. Whatever theta B is there here, which is equal to theta C. Otherwise theta C is equal to theta B here. That's what they tell. WA cubed divided by 6CA. Okay. So I have determined the rotation at the free end of this cantilever. The rotation at the free end of this cantilever is nothing but the rotation here, which is WA cubed by 6CA. Because already we know this case, no. Please remember, recall. Already don't get confused. You have to, okay, here, this one. Already we have this, no. So we know the deflection at the free end, which is W, what is that? We got WL power 4 divided by 80A. Rotation is WL cubed by 6CA. Rotation is WL cubed by 60A. WL power 4 divided by 80A. The problem just now we have seen, no. In that the UDL is up to a length of A only. Okay. That is why instead of L, you substitute A. WA cubed by 6CA. WA power 4 divided by 80A. Okay. So like this. Just see this problem like this. Okay. So see here. 59 of you are attending. Again, I will take attendance later. Right. See here. Where is that? That problem? Yeah, it's here. Right. No, time is, I don't have watch with me. Okay, no problem. I will stop it after this, right? So this way you have to deal it, right? So YC, theta C, YC I have written here. Next, theta B is equal to theta C equal to this one. I just now explained. Okay. Now the deflection at the free end YB equal to YC plus, I told you in the very beginning, YC plus Y theta C into L minus A. Okay, you have to write like this. So the expression whatever you have got, I have substituted here. This way it can be determined. This is only just a procedure I am telling. This way, when in the exam, if you get any problem like this with the numerical values, you have to solve this way. This is the guidelines. This way you have to solve it. Okay. So the deflection here is deflection here plus theta C into this length L minus E. Okay, that's what we have written here. In terms of rotation, it is written. Okay, you not remember this time I am telling the guideline how to solve the clue. Okay, our steps how to solve it. Right? Some student has gone. Latecomer have come. Okay, right. This is the way it should be done. Next, suppose if you get a similarly YB. Yeah, YB is written here. No. Yeah, this is what it's again rewritten here. No problem. Next, yeah, please remember. Just I am telling in the exam. Suppose you get a cantilever beam subject to UDL here. Here it is spread over a length of A near the fixed end. Okay. Suppose the spreaded length is near the free end like this. How to do it? How to solve this kind of cantilever beam? For that, what to do? Please see here. You have to divide this beam into two like this, superposition. The superposition technique, right? Please see here, superposition technique. Okay, now 60 have come. I will take attendance at the end. It's okay. And now, please see here, this beam how to solve. You have to consider it as you have to apply superposition technique, right? What to do? You consider a cantilever subject to UDL fully. Okay. And then another cantilever subject to UDL near support at upward direction. If you put like this, the load is acting upward. If you put like this, the UDL is acting downward. If you put like this, the UDL is acting upward. So this problem minus this beam. This beam, this cantilever beam minus this cantilever beam is equal to this beam. I have written minus this is equal to I have written here. This cantilever beam, this manner loaded cantilever beam minus this manner loaded cantilever beam is equal to this beam. Result will be this. Okay. How? Just you see, if you subtract from this UDL, you see UDL get cancelled. Only this UDL will be there, right? Now, what is the deflection at the free end in this beam? W L power 4 by 8 Okay, that's what I have written. YB equal to, so in this case, this YB is equal to this one, W L power 4 8 minus, come to this beam, W into L minus A whole power 4 divided by 8 plus this deflection here, plus this rotation here into this length. Rotation here into this length. That is W into L minus A whole cube divided by 6A is the rotation here into A. This spread here, the length is A here. Into A will give you the deflection YB. YB is equal to this way you have to determine. Okay. Please apply your mind and think over what I just now I told you. You have to apply your mind and think over what I have told you. Just apply your mind and think over. This way you have to solve it. Right? If you don't follow, please again go through. Please again I am telling. Just now I told you a cantilever beam like this. Suppose in the cantilever beam the UDL is acting at the free end, spread over length of A here. Okay, acting at the free end. How to solve this kind of problem now? By following superposition technique. Okay. See here, we have a cantilever subject to UDL fully. Cantilever subject to UDL at support. Okay, that is near a fixed end. This minus this is equal to this beam, right? We know the deflection of the free end of this beam. That is W L power 4 divided by 8 minus this case. This deflection you have to deduct. This deflection minus this deflection you have to deduct. How to deduct? The deflection here is WL minus A power 4 by 80A. This is L minus A. Okay. Plus the rotation here, the slope here is WL L minus A whole cube will be 6A into this length, which is A. Okay. This way it should be done. In the examination, you will be getting numerical values. This kind of problem. This kind of problem with the numerical values. This is the way you have to solve it. Okay. This way you have to apply your mind and think and solve it. Okay. Actually, many people don't know the difference between school education and college education. As I told you, you are doing a professional course, engineering course. We cannot do spoon feeding kind of teaching. I will tell something. You have to apply unless you learn yourself. You can't. Okay. It's not very easy to teach you. Okay, I tried my best to explain you. It is your duty to sit and spend time and get it clarified. Either you have to approach me or you have to approach a student who is very good, who has understood in your class. Okay, this way you have to learn things. Okay, if you have your own mind, you can think over it. You can apply your mind and learn it. Suppose you are not that much intelligent to understand or follow. What to do? You have to try first your level best. In spite of that, you are not able to understand, you have to come to me. Okay, I will clarify your doubt. Otherwise, if you don't feel free to come to me, what to do? You have to discuss with your classmate who is studying well, who has understood well. This way, hard work. Okay, please remember the remaining portion because we have seen plenty of things. Because it's a subject easy, it's an interesting subject. Okay, I hope you will follow because today we have seen simply separated beam and 2 more cantilever beam. How to solve? Okay, this much we have seen today. I think more than sufficient today. Now just a few minutes wait. 62 are attending class. I just attendance purpose. I want to just wait. I am taking attendance few minutes because it's recorded. Why I am not getting recording screen here today? Is it recorded? Rahul?
Sir, recorded, yes, sir.
Recorded, okay. Screen is there, yeah.
Yes, sir.
Yeah, screen is not visible.
You close the PDF, you might be
oh, that's why I am not able to see. It's okay. Okay, I will slowly move. Yes, please, your names are recorded, right? All your names are recorded, don't worry. So, attendance purpose, we are doing like this. Your names are recorded. Whoever attended, your names are recorded, right? It's well recorded. And during class also, don't do chatting and all. Everything recorded. You have to be attentive. If you do chat with your friends, that clearly shows you are not attending the class. Okay, you are not attending. That is the meaning of it. That is why I advise you be attentive. Don't do chat and all during class. Be serious about the class and subjects, and be have curiosity to learn things. Okay, just a few minutes. Today class is over. First, let me to stop the recording first. Okay, so yeah, so I will stop recording now.